Yeah, I'm not making a class. Well, maybe I should, but I want to concentrate so much on the 64-bit built-in unsigned int that I think having single bytes are a distraction. And I'm assuming that it isn't even worth of making a class for it, as it were. Well, maybe it is. So I don't know. But at the moment, I'll use this line here. Card is just 1 byte. Because I definitely need to make this constructor here. Yeah, let's see how we can do that. I have a feeling that there is an assembly instruction to do this, but maybe let's not get overboard and just do it in C++. I think I already did this, to be honest. Let's steal my code from yesterday. That would be this one. In this case, this is just card, and card prep is where we want to put everything, which is mcards. I'm just gonna place it with mcards. I'll add a comment to show how that works. So we have 64 bits. Let's do it as a hex. So assign to a unsigned 64 and a byte, then everything is 0 except the last byte. We have 8 bytes, so that's 1, 2, 3, 4, 5, 6, 7. And then let's use CC for the card. Maybe that's not clear, using XX. Maybe also not clear, because I have an X here. Yeah, why then? So then we shifted 32 bits. And then OR it with the original. Hey, Post Bunny, well, I just started. This is all I typed, so you didn't miss anything. And isn't it awesome that you did chores? I did too. I went to shopping. Let's see, 1, 2, 3, 4, 5, 6, and then the Y's go here. Yeah, so we shifted to the left 32 bits, that's halfway. And then I shift that 16 bits. So now they also appear here. And then finally we shifted another 8 bits. So yeah, now we just have to, maybe I should have used YZ, because they're not, necessarily the same. And here we have YZ, 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 and I still think that it is hard to read because of the 0x in the beginning. So I'm going to substitute all the Y's with a capital Y and all the Z's as well. No, it should be good. So YZ here is a single card. Okay, what else do we need? Post bunny, because we only have 3 values per characteristic. There simply isn't a 4th value. And I picked 0, 1 and 2 as the 3 values of the 4 possible values that 2 bits give you. Could have picked any other combination, but I doubt that makes it simpler. Okay, what other constructor do we need? I can't think of any at the moment. I'm going to write my print on again. A way to print all 8 cards. Yeah, you know what? Yeah, I can use 1, 1 to signify a card that doesn't exist. Good idea, Post Bunny. Pretty random, but I can do it. Let's put all the cards, all the existing cards, on the least significant place, right? 8 cards, or for n most significant bytes when there are only 8 minus n cards. Now I still want to do this as uninitialized because usually a default constructor is being used to construct something and then assign to it. So it doesn't really make much sense, I think, to give it a value here and then immediately override it. And in this case, maybe we want to extend it to constructor card existing of n times the same card. I'll make it lowercase n. And I'm just making here. And now I made it myself difficult. No, I don't want to do that. I think I'm gonna need it to really have it 8 of them. I'll make a new constructor especially for that. construct a card 8 existing of n, it is time so, of n times the same card. Card 8, card int n. Now give it a default, you would say, but then you get into problems with this one, because then it's yeah, if you don't supply an n, then it doesn't know if it should use this one or that one, so you cannot use a default. It's kind of sad thing. But well, now this version is definitely going to be slower because so I think we have to just, you know, use a loop here. So I'm going to fill it with cards as unknown cards. Then I add here a static const expression int 64 for as unknown cards, which then means that we have 8 unknown cards. 1, 2, 3, 4, 5, 6, 7, 8. Now, normally, by the way, if you just type any literal, it's an int. But an int is 32 bits, so this doesn't fit in 32 bits. But the compiler is smart enough to understand that if you type something larger that doesn't fit in an integer, that then it isn't an integer. Otherwise I would have to add something like unsigned long here or something. You can use that. But yeah, then is it a long or is it an unsigned long? I mean, it's the long, I mean. I think a long on my machine is 64-bit and a long is also 64-bit. But other machines, a long is 32 bits. So I don't like this at all. I'd rather specify exactly the number of bits. You can also just say, I want all the bits to be set, which is usually done by assigning -1. So you could, for example, do unsigned -1. Then all the bits are set. Or are they? Maybe it translates this to 32 bits because it's an int. 32 bits that are set, and then makes that an unsigned int. Yeah, it's not that easy. It's not that easy. We'll have to check if this works. I think it does. Okay, so I'm using that anyway. So the whole problem of what to use here, you know, it's a bit vague. I know I want to say all bits set, but how to write it? So put that into a static const expression. Give it a name, and then use that name elsewhere. You might even use it more often than once. No hard coding of literals here. It's bad enough that I did that here, but well, this 32 reflects on the fact that this type here is 64. And yeah, I could have even made this a type def, or using, and then converted that into these numbers. But then the number of lines is varying as well, and it gets really too complex for the moment for this simple program here. Okay, how do we fill it? Well, I filled it with unknown cards, so now I need to loop over the n cards that we want to assign. And then we realize that that isn't even easy at all. Well, how do you assign a byte in the middle? Yeah, you cannot. I mean, you can, but then I would first have to reset the bits and then OR with it. Or I can do an exclusive OR with an exclusive OR of the card with FF. But I think I know an easier way, simpler way. I just fill it in recursive. So mcards becomes itself shifted 8. So I just make place plus, or I mean now there's 8 zeros on the right, so we can use plus, or you can use let's not use plus because it's more like a bit pattern, right? God. So we shift the card in from the right n times. Now I have to test stuff, so I would say printing is very important for debugging purposes. I always like to use a print on, because then you can just access your members without having to put that's nonsense, sorry, it looks like that. Without having a variable in front of everything, like you would have to do with the standard stream reference operator. Less than, well, this cannot be a member, it must be a friend. Standard stream reference. And then we need to use a parameter. No, now we have to type card 8 in front of everything, but I'm just going to call print on, and then we're done. Turn OS. You can even automate this. I did that in my normal projects, that I don't have to type this at all. Simply the fact that how come that you are 3 minutes behind? Strange. Okay, print it. You might want to print this as a part of a longer series. So print one card 8 after another. So I'm definitely hesitating here with adding braces. I think I just should print all the cards and then something in between. Let's use a separator that is defined somewhere else. Cannot really pass it to print on because I cannot pass it to this. I could use a custom OStream manipulator, which I also have in my library, but I want to make this program standalone and simple for that matter. Maybe I should just choose a separator, like a comma between the cards. Anyway, yes, we want to print them byte by byte. And I want to print them from most significant to least significant. You can do, well, let's just count I. So the card, what we're talking about here, is M cards shifted. Now the first, I want the most significant byte, so this is my full thing here. I want that to end up here, right? To ultimate the end. So if we have this, we want to end up with that. So I want to shift it 64 minus 8. Which is 56. The first time. But if I get one larger, I want to shift 8 bytes less. Minus 8 times I. And then if we shift it only halfway, we get something with multiple bytes. I just really want only the last byte here. So I also have to do an AND with just the last byte. This should give me first the most significant byte and then one more to the right, etc. until we get the rightmost least significant byte. And then if the card equals 0xff, that's an unknown card. Maybe I should hardcode that as well, right? Or not. I already have this as well, but this is the a mask. I think these things just have to be hardcoded here. I might as well hardcode that one. I don't know. Let's be inconsistent. So yeah, we skip all the unknown cards. I'm just going to print the known cards. So a card may not be an unknown card, and then we are going to print it. And I'm doing that with a free function, I think. Print card on. It must be a free function because my card is not really a class or anything. I'm going to print on OS, I'm going to print card. But I also have to print my separator. Instead of prefix, I'll call it separator. That's a better word. Separator. And we begin with the separator being empty. So always needed. That must be nothing. And then after we print at least one thing, then we can set separator to. And note that this is branchless. This trick. So you have to assign it now every time, but that's cheaper than that you have to check if it is the first time and then skip something. Or I don't know, I never benchmarked it or anything, so prove me wrong. But this is what I usually do. Okay, I have to make this free function for a single card. I might as well make this an an int 8, which was a card. And then I don't need to do this anymore because it's already assigning an 64 bits to an 8-bit value type. I mean, so your card was this, and I will already just get the last byte. Okay, so now you have a card which looks like in binary. Yeah. So P. Nah, forget the 0B. P, Q, R, S. That's 8 bits. Yes, and then each of these is a bit pair, or say PP is the value of the first characteristic. The first one that we print anyway. So, but yeah, I don't know. Should I give them a number? I'm inclined to call this characteristic 3. Which is also not really English, because we are going to have a characteristic 0. Well, normal people start counting from 1. Cases like this. So we have 4 characteristics, and we print them in this order. Want to print them in this order. Well, got to have the loop, I guess. Or we can use a modulo, but feels slower. No, that's nonsense. Yeah. That's very funny. Post Bunny said, dang it, I'm not normal. I always start counting at -7. Haywarton, yeah, when I typed it, I said that it might not work. So the idea is that all the bits are set. But we'll test if that is going to work, you know. Maybe only 32 bits will be set, because this is an int. Void, let's see, int I, use I everywhere. We are still counting upwards. I less than, now we have 4 pairs, 4 bit pairs. And I want to begin with so that's almost the same as what we did below here. Almost the same. Where is it? Yeah. But of course we do not want to shift it 56, nor do we want to update it with 8. This time we want to bit pairs, so 2 bits, and this is 6, 8 minus 2. So when I is 0, then we shifted 6. And then in the end we have to do an AND with 1 1. Binary 1 1. And this whole expression here now gives a bit pair starting with the most significant one. So first PP and then QQ, RR and then SS. And we want to print that one after another as is described in the description of the video. Simply in the decimal form. I think that's it. Now, if you want to be really, I think the compiler is already smart enough to optimize this to the absolute maximum. So it's more about readability than anything else. But of course you can rework I. For example, I could change I. Let's say if I remove this 6 here, then to correct I must be 3 less. If I starts now at 0, if I started at -3, oops, then times 2 is a 6. I'll do it as an example. So we remove this. Then we must start at -3. Like that. I just subtracted 3 from I. And then we start at 6, shift 6. And then if I gets 1 larger, we shift, that's -2, so then we shift 4 bits, and then 2 bits, and then 0 bits, because it must be less than 1. Of course, you can also multiply I with -1. So I multiply with -1, so this is removed. Then I have to multiply this with -1 and multiply this with -1, but that means that this must also, be negated. And then this, goes the other way around. Let's see if that still works. Now I is 3. We start with shifting 6, that's what we wanted. And the feeling that this doesn't work. You must now, of course, have the values 3, 2, 1 and 0. So this must be larger than -1. Not larger than equal. That's more like when you do a not on the expression. So the last value is 0. We shifted 0. And the first value is 6. That looks good. And then we can divide we can replace I with the double the value. So I'm just going to use I now. And then of course means that we must start with 6. And well, I could even make it a 2 here. And this now must be going down with 2 at the time. So we start at shifting 6 and then 4 and then 2. And then 0. And then we get -2, which is no longer larger than the -2. So, but of course we can make this a little bit more sane, like larger or equal 0. And maybe I should have done this immediately. But I feel that even with the code that I had before, that the compiler would already do this. I don't think that the precedence of this expression is correct. Probably have to do it like that. Okay. Well, if anyone thinks that this is more readable, we can do the same here. This also starts a shift at 56 and ends at 0. And in this case we want to go in step of 8 bits. So no, it's just I. But now I is hardly an index anymore. Before it was an index of a byte. So this is more a shift. I'm going to rename it to S, I think, just to make it clear that it is no longer an index counting something, but it is the amount that we shift. The level at which I'm commenting this is aimed at beginners, because I have the feeling that most of my viewers are beginners. But if anyone thinks that I'm going too slow, so enough people say in chat that I'm going too slow, then I will not put as much time in the trivial things like this. Okay, so we have some code now that we can test, I guess. You can try to print stuff. So start doing it. So I want to make card 8. And that would be uninitialized. So I'm going to initialize it with a card. And let's just use 10, 01, 00, 10. Do stay away from 11. And then we should have that card 8 times. I think I can just print it. Now let's see what this breaks. Yeah, everything was right. This is not allowed. Now I couldn't make it UL, but let's just go back to. I mean, what else can you do? Something minus. I don't know. There's many ways to do it. I mean, I could do, for example, 0 minus 1. That would work. I don't like this. Let's just fill in the 8 bytes of Fs. So that seems to have worked. Prints 8 times the same thing, and well, 2102. So that will be 2102. All the code works. Yeah, I think it works, but it's complaining about narrowing. So I'm still not sure if it works actually. If we ignore the warning, but I'm not going to ignore any warnings. I think there's maybe the usual trick is to cast it. For example, you could do this. You int 64 type -1. I'm not even sure it will shut up then, because it still might be complaining about narrowing. On the other hand, I mean, it's -1, and oh, sorry. Yeah, hey, right then. I didn't see that you left out the U. Yeah, you're right. But now, the narrowing has nothing to do with going from 32 to 64. That's even widening. But from the fact that we go from signed to unsigned. So it's not really narrowing, but more like certain values would change. -1 would change into several billion. Well, how large is that? 2 to the power 64 -1. So yeah, it's not really easy to get the compiler to shut up when you go from negative to unsigned type. So I'll just begin with unsigned type from the beginning here. So this is, by the way, still an int. This doesn't fit in an int, and normally if you don't put an u behind it, it is an int. Therefore, it is signed. So, but yeah, okay, it's a literal. So the compiler in this case shuts up and it just says, well, okay, you forgot to add ul, but I understand what you mean. Okay, well, anyway, what is the next step? Yeah, I think that belongs in this class. Something, and that returns a card 8. Think about abusing an binary operator. I could use a plus or something like that. But maybe you should not. Yeah, let's use just a name here. Card 8 is what it returns. Yeah, it's still... It's symmetrical, but if I write it like this without using a binary operator, it's so asymmetrical that I hate it. But okay, let's do it anyway. I'm gonna call it match or FindMatch, right? Oh, you use it FindMatch. I used FindMatch yesterday, so let's do that again. So this function is const. So we have 8 cards. This is 8 cards, and I'm passing another 8 cards. And then I want to return the 8 cards that form a set with each pair of the 8. So for 8 sets, basically. Yeah, now I'm a bit worried about what happens with the FFs that I'm using. That becomes nonsense then. I don't really want that. Well, I don't know. Let's first add the code required for doing this as if there's no unknown card. I think there shouldn't, but should never be an unknown card. I don't know. Oh, there is one more thing that we can test. Here I constructed it from a single card, which then turned it into 8 times the same card. But I can also construct it, say, with 5. And now we should get just 5 cards. Hey, that works. So let's see. Also work with 1 card. Yeah. Get just 1 card. Yep. Great. And now I was working on this FindMatch. Okay, so let's have a look at my code from yesterday again, because that contained all the magic that I cannot remember anymore. This code here. Yeah, I'll just copy it, I guess. FindMatch with 2 inputs. Right, and I think that we can do, okay, replace K with result. Card 8 is M card. So K then becomes result dot M cards. And then in the end, K is exclusive OR, and we want to return that, but we want to return the result. So instead here I'm going to do result M cards. Oh, that was K. Exclusive OR with M. And the inputs here are, well, actually the original M cards itself, right? So this is exclusive OR between the 2 inputs, but I can just do an exclusive OR with itself. And input 1, which is then card 8 that is being passed. Dot M cards. Nope, that's not what I wanted. And it's not true. It is, of course, the current object. M cards, exclusive OR of that. And this looks a bit weird, you know, constructing it and then assigning something in the middle. I mean, a private member. Might as well make a new constructor. So we need a new constructor that takes an unsigned int. But hey, this is so internal and it doesn't need to be public anyway. So I'm gonna make it private just because it is the only place where I'm using it right now in this function. So I can do used by FindMatch. Okay, I'm still having another case here. K is still result .m cards. Okay, can I give M some kind of name or not? Shall I just skip it? No M. Yeah, okay. Now that was our bit magic that we figured out yesterday. And I think, is it working? Well, I think she has a point. I put it here in the middle and above there is something public. But on the other hand, it feels like it's not that bad a place, because this is a constructor, this is a constructor, this is a constructor, and this is a constructor. And this is only used by the function immediately below it. So if I move it just to get private away from all the public functions, then it only is being moved away from all its brothers and sisters. Boys Bunny, you have a dirty mind and you're distracting like that. Damn it. Funny, but yeah. Okay, I want to test this or not. Nah, this just works. This is code from yesterday. I'll test it later. Let's concentrate on the actual code that is needed to brute force this thing. So we're also going to have to have a class like yesterday called table. So that's all the cards are on the table. Actually, I'm going to need something else first, I think. We're going to need, I think, a translation table, which might be handy. I made yet another free function or something that is not wrapped into a class. But I'm more interested at the moment in getting the program to work than writing super clean code. Normally you would have to, or you should wrap all the global stuff in a class and then just make that class preferably a member of main and then work with that. But in this case I will just make global stuff, which is a bad thing, okay? And you want to stress it. Don't do this at home. But okay, global stuff. I'm going to make an array here that transforms enumeration of all the existing cards. There are 81 cards. So I want to go from an integer, which is then the index into this array, to a card. And then there are 81 of those. And then this is, I'm going to call it static, even though it's just global, or maybe it's just global, like that. A global array, which is translates, well, you have to give it the name. Card index, I guess. The 81 is just, let's call that card index. I just call it index. Otherwise you have card twice. I'm going to fill it in the program. I could hard code here the whole value because it's just 81 things, but let's be lazy. I also want to be able to convert the other way around, which means that, from card to index. The maximum value of a card is yeah, 2222, which is I guess 2 times 27 plus 2 times 9 plus 2. Okay, I cannot calculate. 2. I'm ashamed in advance that I could not do this from my head. I was close. 2 times 27 plus 2 times 9 and then plus 2 times 3. Yeah, plus 2. Great. And that, can I do this from my head? Claude, yes. I tried that yesterday and my conclusion is that it is extremely stupid. It has no awareness, no memory, no understanding of what it is doing. It is nothing more than a glorified pattern matcher that produces stuff that looks like English, that is correct. I ask it to write my code. The code, look at the video of yesterday, Claude Brentix. It produced wrong code. and it claimed that it was working because it couldn't figure it out. It doesn't understand C++ at all. So I asked it a difficult question, or I asked it basically to come up with this. I asked it to produce this code, and it couldn't. And it couldn't 10 times on a row. Every time I pointed out what was wrong and asked it to fix it, came up with something else. Every time it was pure nonsense, and it didn't even fix the exact one, exact example that goes wrong. For like I said, yeah, but it doesn't work. If I input 0 and 1, the result is 1, and it should be 2. Oh, sorry, you are right. I have fixed the example. We can fix this problem by doing blah 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 blah, and then it correctly gives the right output. The complete program looks like this, and now it will work with both the same values and different values. Please note that it will only work for inputs 0, 1, and 2, and not for 3. Now I run the new code. Still 0, 1 gives 1. It sounds nice. It sounds like the right answer. It comes up with something random that sounds like the correct answer would sound like. But it's not the correct answer. It is only something that is random and sounds like it. I'm extremely disappointed. I wouldn't even call it an AI. It's too sad for words. Completely unusable. So for now, I take 100% back that you have to be afraid that AI will take over your job if you become a programmer. Because man, they have a long way to go. No, Boss Bunny. It's really exactly as I said. It is it made the code. It produces the code the same way as images. If you say draw a teddy bear on a bicycle in New York, it draws something completely random. It literally starts from noise. And the only demand is that what it came up with, it would classify itself again as a teddy bear on a bicycle in New York. So you get pieces in the image that look like New York, you get something in the image that looks like a teddy bear, and you get something in the image that looks like a bicycle. And that's very impressive, but that doesn't work for C++ code. C++ code is way too exact. You cannot diffuse to code. You have to understand the code. It was very clear to me that ChatGPT does not do any reasoning whatsoever, and it was lying to me, and it was being inconsistent. Tested it. I started with testing it without code, and that was a pure horror. That was like talking to Eliza. Like, what the fuck? I'm talking to a dumb bot. Get me out of here. It repeated the same thing over and over. When I said, don't say that, it just did it anyway. When I said, can you remember what I said? It says no. Well, not no. It said the same thing, the full paragraph again and again. Basically saying, I am a big language model and therefore I cannot remember and blah, blah, blah. I kept repeating the whole sentence over and over. Even when I asked it not to. But okay, it was clearer and clearer, and it kept saying very clearly that it was not able to remember anything from before the last prompt. So I would say something, and then it would complete it. And I would not know what I had said before that. That's what it told me over and over. So then I said, okay, I want you to reply with a single word. Say acknowledge when you understand. And it said acknowledged. And then I typed in say that again. And it said acknowledged. So it knew very well what the prompt before my last prompt was. It did remember something. So it had been claiming like 6, 7, 8 times on a row that it had no memory whatsoever and could not remember anything from before the last prompt. And then I proved it wrong. And then I said, well, you're lying to me, blah, 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 disappointment. The same answer. I'm a big language model, blah, 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 blah. That was as stupid as the rear end of a pig. No, he was not lying. He did also not remember, I guess. It's just producing text that sounds like the text that you would expect in the current conversation. It doesn't matter if it is true or not. It doesn't check it. It doesn't have to be true. As long as it looks good. As long as it looks good. So, for example, people say, give me a short description of quantum mechanics. Yeah? And then you get a paragraph that very much looks like as if it gives you a short description of quantum mechanics. But I didn't test that one, but I'm pretty sure that it might as well be complete nonsense. If you really understand what is going on, then it's just pure nonsense. It only looks like it. So it's really completely useless. Completely useless. I think I'll let the compiler calculate that. Okay, there's another global. This one is card to index. José Leandro, Varon Carrieno. Really? That's a long name. I bet you never get collisions. Oh yeah, username already exists. But yeah, hi. No, I tested. Someone in the chat said, "What is your opinion on Chat GPI?" And I said I never heard of it. That was a few days ago. So yesterday I did look it up, tested it, and I lost all interest in it completely. It's worthless. Let's do something else. I'm going to fill these tables here. Index 0 less than 81 plus I. Index to card I is card. We start, of course, with a card of 0. And then in between we have to increment this card to the next card. Yeah, I wrote also code for that yesterday. I'm not too sure if it's very useful, very worth much. Certainly this is a one-time thing. 81, might as well. I mean, still have there. I wrote this. So that's branchless, parallel-ish, going to the next card. But, you know, not really needed. Let's write some code that is simpler. What I really have is simply 4 characteristics. Characteristic 0. Is less than 3. And we have 4 of those. No. I'm just doing this for one more day, I think, and then I'll have to go back to my Vulkan engine. I think that's correct, isn't it? Well, apart from that, I didn't increment I. So I just filled one lookup table. And let's print everything, just to see what the result was. So now I can use I, or, again, is 0 to 1, or it's going to warn me that this is hiding that I. We'll see. So 81 plus I. And then we can create a card 8 from what we just filled. But I just want a single card. And then we can print that single card. We already had that code here. And we don't know what input 0 is. That's a good one. God. We don't know what array is. Well, that printed 81 times 0, 0, 0, 0. What went wrong? What went wrong? I have no idea. Let's print what is in my table. Wait. Let's not print what is in my table, but let's print what is in my table after I cast it to an int. All zeros. Okay. I think that works. So why is my table all zeros? Because I'm an idiot. Did search and replace and I changed my initial values. Now it looks good, I guess. Okay. The next lookup table, this one is reverse. Reverse. Okay, just put in a card by the value of the card. And I should get the index. How does that work? Okay, guess that works as well. How can that not work? Now the table. I think what I want to do is I have a bunch of cards on a bunch of card 8s rather. We need to make copies, but yeah, we need to make copies of this table a lot, I think, actually. So but yeah, well, not making copies would be nice, because that's pretty slow. I'm not sure how I would do that though. I'm going to do some kind of recursive search. So we change the table. A table, by the way, means a desktop table, which you can put your cup of coffee on. So just we lay down the set cards on our table in front of us. That's how I meant the table here. So you put more and more cards down, and then at some point we want to reset, go back. So take the cards that or the last card that we put down must be picked up again, and then we try another card. Kind of way. It might be possible to do that by simply remembering the number of cards that are on the table. Because, I think I only want to back up, kind of like a stack. You push stuff to the table and then you pop it again. Maybe that's how I should treat the table, as a stack. So I'll have a pop and a push function. It's not that easy, however, because I really also wanted to have the table immediately to keep track of everything else, namely the number of cards that are not forming a set with cards that are on the table. So I don't have a good plan really, but probably we need, let's say, the number of cards on the table. I'm not sure yet if I'm going to copy table. I'm going to try not to make copies of table, which I doubt if this is possible, or maybe just a part of it. I don't know yet. If I'm not making copies, I might as well make the table large enough to put all 81 cards down. All 81? Because I'm going to work with cards 8. Card 8. So we make that size 10. Then I can put 80 cards down. Would it be enough? It like really sucks to make it one larger, right? Just for the last card. Well, I'm probably never even using it. But hey, if I'm never copying this thing, then it doesn't matter. Just a little bit of memory that sits there. So all cards. Now let's leave all the way. Only number of cards. And we store that then as follows in here. Okay. Yeah. I also need to keep track of something, however, namely the number of the index of the cards that do not form a set. Do I really want to work with index? Is that faster? I mean, if I'm not working with index, I don't need to look up tables. But it will make something of a size 81 this big. Okay, I have to calculate it. It's probably a logical 3 times 27 plus 3 times 9 plus 3 plus 2 is 113. No, it doesn't sound logical. But hey, it's less than. So it's really 113. It's 80. What a made a mistake. Yeah, yes, of course. Oh my god. And you see how stupid I am. 81 cards. 0 is the first one. 80 is the highest one. But, no, why is it not 81? Okay, no, I mean, it must be 80. But 2, 2, 2, it's just simply 2 times 3 to the power 4 minus 1 or something like that. No, not 2 times. Oh my god, really? Yeah. 80. Well, since 80 is less than 81, there is absolutely no reason whatsoever. No, this cannot be true. This cannot be right. How is it possible? How can I put 81 cards into... I'm so confused. It is not true. It is definitely not 80. And I think I was confused with using... I'm definitely confused. Damn it. Okay, I'm feeling really stupid now. Encoded. This is the largest value, right? This is 2222. That's the largest value. $170. Seriously. It's okay. So how is that logical? It's not logical. I don't get it. Anyway, bit set of is probably stored as 64 bits. I hope. So 81 divided by 64 is obviously less than more than 1 or less than 2. So I would use 2, and 170 divided by 64 is between 2 and 3. So that would be use 3 things of 64 bits. So it's just really Yeah, I'm gonna use this. Just simply buy card. And then these are the cards that are available still, so that do not form a set. Or maybe the other way around is better, that you cannot use anymore, unavailable. Unavailable. Okay, I'm going to begin with a table which has a single card. And well, the card 0, also a single card. Wait, M card is an array. How do you do that? Array. Yep. An array. Fill the array with elements, and well, the first element is a card 8, but you want to fill with one card 0, like that. That should work. And then the rest is filled with default constructor card 8, which I think are indeed not initialized, which is probably not what I want now, but yeah, totally not initialized. Well, hey, why not? I shouldn't be using it, I think. And then the M unavailable, we just fill with all zeros, and I guess that the default constructor will do just fine for that. Okay, how do we print a table? Oh, let's put this one between braces. And then we print, I guess, for each. I need to know the largest one. So does this one round up to multiple of something? No, just, yeah, well, yeah. It's your number of card 8s. The number of card 8s. So 0 gives 0, 1 gives 1, and so on. 8 gives 8, 8 gives 8, 8 gives 1. Y is 0, y is less than the number of cards. Plus I. And then we can work with m cards I. And I simply want to print all of them, I guess. And I also think it uses commas, right? Yeah, commas in between. Let's go zip. The separator. I'm not beginning with abbreviations. Okay, let's test this. Let's keep that, yeah, for now. I'm going to make a table, T, and then we are going to print that T. Into card 8. It doesn't want to do that. Okay. Wait. Card. Just constructing it like that. Oh, it's still the same thing. From into card 8. It's the second thing. It's not understanding what I want to do. I want to construct a card 8 here. Dude. I think this should work just fine. Maybe I should have added braces, but hey. Expected primary expression before 4. Yeah, okay. I'm an idiot again. Okay, on the table is one card. The card 0000. But there's something missing because the unavailable, that means the cards that are not allowed to be added to the table. It's obviously what is on the table cannot be added. So we also need to set the bit. We need to set 1 bit in bit set. How do I set 1 bit in bit set? I have no idea. So a constructor for that. Construct a bit set initializing the first, right, most, least significant m bit positions to the corresponding bit values of val. Where m is the small of the number of bits in the unsigned long and okay, you can just construct it from a long to, yeah, clear enough. So bit number 0 is set because the card is 0. Maybe I should make a card. Make card 0 here. Okay, let's make card 0 here. Static cons expression card 0. Now that's interesting because now I'm passing an unsigned 8 type. But I guess that is a basic string. Oh, size type. Yeah, no. The first here one is a pointer, and the first here one is a string reference. So it definitely has no other choice than to pick this one or that one. Just going to convert my card 0 to an unsigned long. Right. No. What is the next step? There's one card on the table. I guess I do want to print it. Yeah, I don't know. I'm just not going to use this, right? Not going to use it. I do need to run over all the cards though, but I can use my other encrypt. Let's keep it for now. Okay, let me think. I guess we have to call a member function on T which adds one card. Add one card. Let's write that one. And yeah, the only way I think, at least the best way that we can do that, is by indeed running over 81 instead of 170 bits. Is that faster? And I do have to do a table lookup in order to find the index into this bit set. Which makes you wonder if maybe I should not, store it as a bit set of 81 in the first place. I think I'm going to do that anyway then. Okay, so that's now a card index instead of a card. And we're going to run over all possible cards. Well, not 0, because I'm 100% sure that that is in use. And now if unavailable, yeah, how do you test that? How do you test if a bit is set in bit set? Excusez-moi. Access specific bit. Operator square brackets. Continue. So go. We skip all the unavailable cards. So it's not really adding just one card. It's going to add one card, but all of them. All possible cards. But we are only adding one card. Okay, we have our first card anyway. So now I want to update my table. I have to put a card down. Yeah, let's start at the top. Obviously, the number of cards is incremented by 1. And suddenly not too sure anymore if remembering the number of cards is smart. Maybe I should just remember the index into this array and have a mask or a shift into the card 8 that it points to. What do you think? What shall we do? What shall we do? I'm going to It's more the index into card 8 index. Yeah, I need to make a mask. I think I want to store the mask. Rohit, no. Next card mask. Oh, that is the next card. Yeah, so the least significant byte is used for the first card, which you just which we are filling, and then the next card is going to be the next card, the next byte. I mean. Okay, I'm just going to code in the card 8 index directly. Instead of storing the number of cards. So we're currently in index 0. And then the next card mask is that. It should work. The rest doesn't change. Except of course this, we already have that now, and this one, well, you have to increment it. First want to fix everything else that is using it. Ooh, only this function. We were in time. Well, this then becomes indeed just current index, I guess. Let me see, this must be less than or equal the current index. Yes. Okay, back to this function. We just added a card. What does it mean? Well, that means that if this thing is not that big like this one, it just has to be shifted 8 bits. Come on. But if the result is that then it becomes 0, then we have to increment card index and reinitialize the next card mask to 0xFF, and except that is not true, because now this is the index of the next card mask. Dang, 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 dang. And I wanted to have it, wanted to be the one that, you know, of the last one that is in use. So, yeah, it's not true. Nope. Only until it becomes this after shifting. You have to increment this value. Well, that means that we just filled in this, and therefore we just entered the next card 8 in this array. So now I updated this and this. Now I have to update M cards. Well, that's an easy one then, or it isn't, because I need now the shift. Bloody shift, I need shift. So maybe I should not have remembered the card mask, really. I should have remembered the shift, I think. Let's do that then instead. Tiresome, isn't it? Maybe the last one. What I can also do, yeah. Let's make it current. Look. Okay, on index. So let's say this is the index. In the index into M cards of the last added card. That's what it already was. And now this one I'm going to make the shift in bits of the card, of the last added card, I think. Yeah, blah, yada, yada. Okay. So it's not next anymore, it's just a card shift. And that's then the last added card. So we really begin with 0, 0 now. It's no longer correct. Now I still have card index, which still works. But it doesn't work anymore. I don't have a mask. I'm going to increment this with 8. Card shift. And that's enough, unless M card shift in now equals 64. It's just too big. Then it has to become 0 again. And we must increment the card index, because now it's really the current card. This makes much more sense, right? Yes. Okay. Well, it's time to get my card. Let's call it new card. New card is this one, index to card. Oh, no, this index, all of them. And In fact, I can immediately store it in an uint 64 type, I think. Or not. No, I don't know. This reads better. Now I'm going to put it in an uint 64 type. I don't know. Add. Hey, LGL. Rohit, I said no. So new card must be shifted by. Oh, but now I wanted to go to the next card, but I already set it to this one, right? I mean, we just incremented it, so this is the next card. So after shifting it, it becomes at the right place. And then we have to replace the value in M cards. Card index with that byte. So if the value was 0 already, I can just do add. But is it 0? I don't think so, because well, it's an array. M cards. Yeah, it is 0. I filled it with all zeros here, so we can just do an OR. Let's skip this line. So now I added the new card to this, and now finally we have to update M unavailable. But let's first test this before I do that, which means that I just will print whatever I have now. And then we want to undo it again. Because if we would add a new card, then I would just add a lot of cards. So I want to undo adding this and then add a new one, right? Well, undoing it means that this thing must become 0. In a minute, something is wrong, of course, here, because M cards is a card 8, which is an object. Maybe I should use something else here. No, whatever. But I definitely need to keep track of a real mask as well. I'm going to int 64 type mask is 0xff. Shift it the same amount. And then we have to 0 that byte. It means that I want to end it with the inverse of that. And then we cleared. Oh, we cleared it. Oh, wait. All zeros is not what I really wanted then. Hey, Lens. starting to think that maybe it would have been better to use 0, 1, 1, 0 and 1, 1 as the 3 values. But then I have to reinvent this. I don't want to. Yeah, I'm not going to do that. Okay, so I can no longer assume that it is 0. And then I don't have to do anything afterward. Which means I have to do this beforehand. Make a mask. Like that. Index to card, that is a byte. New card. And then I shift it. It's probably not working. I mean, if this is a single byte, and then if you shift it, it just becomes 0, and I don't want that. So I'm gonna really put this into an in64 type. Well, more or less do the same thing here. So you have both. Well, this is already shifted. Let's put it below then, where we need it. So I get in the least significant byte, the new card. Lol. Okay, we get in the least significant byte the FF. And we shift that to the right byte, and then I reset M cards. All the bits that byte is being reset. And then we get in the least significant byte the new card, which is then also shifted and ORed. So then it's put into it. Yeah, and then undoing that means, well, I don't really care what is in this array, because I'm clearing it anyway afterwards. Except then when I print it, it would print maybe too much. And that's how I'm doing it. So yeah, maybe I should put... Why did it work at all? Kind of confused. Oh, no, never mind. Wait, I do mind. Oh, yeah, okay, I'm getting it. So I really have to set all the bits to FFF, I think. Wherever I'm not using it. So to undo it, I have to do that. Set all the bits to all ones again. Guess that works with this. Okay, now we have to undo this. I guess it's almost the same thing, except the other way around. So now I must subtract 8 And when it was set to 0, then it becomes negative. Card shift is an int, right? I'll always use ints. Card shift is not an int. That's nonsense. It should have been an int. Okay, so if now this becomes well, less than 0, then you have to revert this as well. Card shift then is set to I guess 56. Yeah, I think I undid it. I did undid it. 56 plus 8 is 64, and then we set it to 0 and increment that. So minus 8 is minus 8, less than, set it back to 56 and decrement it. And otherwise it's just plus 8 and minus 8. Alright, still have to implement these now, but they are pretty simple. So mcards is array of card 8. And we got to give that operators. Int 64 type. It's very ugly, but whatever. Mcards is just an uint64, so I'll just do the operation on it. No match or call to standard array something. Sorry. Oh, it worked, but it printed in an unexpected order. Yeah, maybe you want to print it in the opposite order, right? So new cards get added at the end. That looks good for the rest. So card 0 was on the table, and it's still on the table, and it remains on the table. And we added a new card, and then we took it away again, and we added another card. And in the end we did add all the possible cards that exist. All the way till 2222. Perfect. Except that, yeah, maybe I want to print the cards in opposite order here. I went through troubles to print it like this. I guess I can see. I can leave it like this. It's good. It's good. So this adds one card at this point, and then undoes it again. How wonderful! But I still have to update one more thing, and that is the difficult part. I have to update unavailable, which means that I have to run over all the arrays here, which you're going to get it's kind of sucky, yeah, suckage. Yeah, I just have to run over the whole array, I guess. Well, only the things that are relevant, so it's kind of like printing it. So like this. And then we have to do with mcards I. Those are 8 cards, but might be less than 8 cards. There are 8 cards if I is less than mcard index. So maybe I should treat the last one differently. Well, and it's more like the complete index. Separate them. Let me think. Yeah, I think I'll just separate them. So I need to find out the last index into cards that has really 8 cards. I think I have to do that before this. Before anything even. All the way up here. If, let's say, the index 0, M card is completely full. We have 8 cards. Then the card shift is pointing to the last added card, which is 56. So yeah, I have to do it after that. After this line. Yeah. After this block here, M card index points to the first incomplete card 8. So if I do it like that, now all of them are complete. All of them have 8 cards. Is that correct? I mean, normally this is 0, so we don't ever enter it. I mean, in the beginning it is 0. Let's initialize at 0. So the first time that we get her is the first time that this is incremented, which means that we just set the card shift to 0. So we are going to add something to the next, to index 1. But then the previous one, index 0, is completely full. So yeah, this is good. So we have all 8 cards are in use here. And then card 8 has this wonderful function here. FindMatch. And I want to match all the 8 cards with my new card. So I need to make an card 8 to pass to it. That just has 8 times the new card in it. And then we can do that by constructing it like this. We get 8 times the same card. So a call FindMatch on it with a card 8 constructed from my single card. Let's call it matches. FindMatch takes a card 8, so I might as well just pass a card. Then it will construct it. So I have to pass my new card here. New card. Where's my new card? Down here. Yeah, new card. Okay. Ta-da. And G index 2 card returns a card. And then we pass that here. And here I need to convert it to an uint first. Well, okay. How shall I call this thing? I'm just gonna cast it here, who cares? Now each of the 8 cards that it returns are no longer available because those are the cards that make a set with the 8 cards that are already on the table and the new card that we just added. So for each of these 8 cards I have to mark my bit, a bit here. And you know, that's going to be hard to reset. I think I have to make a copy of my bit set cursively. But again, let's first just do it as in I have to loop over all the cards, I'm afraid. Seriously? That's yeah. Int J. Okay, let's invent a new interface here. What I want is to reset unavailable, which is a standard set. So that's reset, right? Now I want to set a bit, unavailable, set. So just pass the position, okay. So I'm going to call this dot set, and then Jesus, and then pass the index of the card. And we have here card to index. So now I have to put my card here. And what I can do is, I think, matches and then abuse square brackets or something. J. So we have then the square brackets on card 8. So that's these square brackets here. Should return a card as function of the index. It shouldn't be too hard to add. We'll add it here. We have something card operator square brackets takes an int as index. And then, well, that thing is const. And it returns something. Well, I can just shift it, right? It's a very simple thing as well. Index times 8. So index 0 gives me the least significant byte, because card is just a byte, so that works. And if we shift it 8, then we get the next byte, etc. It does return all of them, but okay, it begins with the least significant byte for index 0. I guess that's okay. Which is then converted to card index, so you have a small bit set here, and then I can set that bit set, and then unavailable is updated. But you have to also undo it. Plus, I only did all the full matches now. We still have the last card index is I is equal to m card index, which needs a slightly different approach. But what? I think I have to do this anyway. And then for I equals m card index. And then we have to do this. I mean, basically you have to do everything exactly the same, except not exactly the same. Now it is exactly the same, as if I had less than or equal here. What I really want is only to do this, only set this for the bytes that are relevant inside matches. Sorry, not, relevant, but they are relevant when the input was relevant. So the input here, when this was relevant for that J. Is that true? Wait, this one, yeah. So you have to do something like if something, then break. So yeah, but still working with 0, starting at 0. So we start at the least significant one. Is the least significant one also the one that we first set? I think yes, that's the case, right? That's what we're doing here. We start with the card shift of 0, so that works with the least significant byte first. So I want to break if like that. I think so. We'll never know, I guess. Well, I'll have to debug it. Looks good. The idea is good. Just run over all the 8 bytes, and then as soon as I get to an undefined card or an unknown card, an unused card, then we're done. And otherwise I do the same thing as I do here. All those bits are set. And definitely a problematic thing here is that then we have to undo all that. I think it's probably the fastest to just make a copy. And then I only have to make a copy of the bit set. So let's make a copy here. Unavailable copy is unavailable. And then undoing that is obviously the other way around. At the end, still printing it here. Doesn't matter where I do it, but let's do it here. Unavailable, yes, unavailable copy. Go back. Right, let's see if this still compiles even and still prints the same thing, and it does, so that worked. Now I want to see it add multiple cards. So we have to remember the number of cards that are in it. Well, that is actually equal to this, right? It's maintained in here. So I'm gonna do. We're going to do a recursive call to add one card. So instead of printing it, I'm going to do a test and then print it maybe. And then we're going to call add one card. Again. But yeah, well, you know, only if we're not there yet. I mean, I don't want to do this. I need a kind of a depth thing. So let's say if we do it just one, we do it just 2 times, and then I have to stop printing because it's already like 81 times 81, I think. So it blows up very, very, very fast. I forgot one thing. Also, the new card must be set as unavailable, so I don't add the same card twice. Okay, I'm just going to have a maximum, I think. Initialize at 0. Can also initialize, like, can do it like this and initialize the list, but you can also do it here with SQL plus 20. And max card shift. These two kind of, know how many cards are on the table, right? Now I'm going to assume that I get here if we succeed to put a card down, a new card. If there is no new card, then I have to do something else also, of course. But let's assume we succeeded to put a new card here. Then we can see that that reflects in the fact that now, well, obviously, but this is incremented, and I want to know if it has become larger than whatever we saw before. Just going to do if the incremented value has become larger than the max. And this one is the one that goes the slowest, so I have to do something like, or it is equal. What the heck, now I have to calculate the number of cards anyway. Maybe I should do that. And it's definitely reading better, and I have to do it anyway, I think. So, number of cards. Sockets. How many cards are on the table? That is card shift. Card shift plus 8 times card index plus okay, so this thing is incremented with 8, so I divide it by 8 again, so I get 1 every time. And then we reset it, so then this goes until 64, divided by 8 is 8, so therefore the times 8 here. I think this is the number of cards. I'm going to do if the number of cards is larger than the maximum number of cards that we saw so far. Then we print it out. And max number of cards then becomes the number of cards, obviously. Remember that. Let me see if it kept track of that correctly. I want to print the number of cards as well. Let's not do this yet. Max number of cards. Something went wrong already here anyway. It says 1 and then it prints 2 cards. What is that? Yeah, so just 1. Just has to increment it by 1, I guess, to get the actual number of cards. Okay, something else went wrong though. I passed here a new card, which is nonsense. Card to index. Okay, now print 2 and it immediately stopped. Why? Oh, because it never got more cards. That's the first time it got that many cards. Yeah, let's print it when it is larger or equal. There we are. Okay, we have it again. 2 cards. Now that works. So I want to call add 1 card if we manage to add a card. But should I not already stop before that? I mean, how does it look like when I cannot add any card at all? I guess the reason I cannot add any card is when there's nothing available, right? But as long as there is something available, okay, if there's nothing available, we do continue 80 times and then we just leave this function. So we won't call add 1 card anyway. But that's slightly a waste of CPU, I think, doing this in a loop. So instead, let's just not call add 1 card when all the bits are set. So if not all the bits are set, okay, how can I test if all the bits are set? All. So if not am available dot all, am unavailable, I mean, if not everything is unavailable, then we can add another card. Now we do that. Yeah, but then we get a really big output or not? No, I'm curious. 28 cards. I must have made a mistake because, yeah, I'm pretty sure of it. There's lots of zeros in it. It's not working. Definitely have to go slower here. Smaller steps. Lens. No. It's not part of the Vulkan engine. Just some hackerage. It bit fiddling stuff. Okay, where did this go wrong? I guess I can extend this with and mcart shift less than 16. That's already a lot of output. But output looks okay. Can still scroll back or not? No, it's just way too much output. Now what theoretically should be doing is only add a card that is not already on the table. And so that would be, this is always there, and then it adds 80 different cards here. And then if there would not be any set, but of course there is a set, it would be add 79 cards here. All 81 except that one and that one. But it doesn't. It also cannot add the card that makes a set with these three. So the correct output for 3 is 81 minus 3. So we have in total, we should have in total 80 for this one times 78. 6,240. And then it would work. So let's test that as in run this, and then I want to see the head for a moment. 20. Yeah, so it finds for the first time 2, and then it finds for the first time 3, and the rest are 3, of course. So we just count the number of lines, we get 2 more, we get 6,242. So that works. Well, I would say let's get them coming. Plus 8, 24. Okay, let's see the raw output. That's already wrong. Aha. Now we can go ahead, I think, and already try to determine how many it should be printed. So 4 cards. That would be so 80 for the second card times 78 for the third card times, yeah, and then we have 78 cards that are not on the table yet, but a set is probably formed with all 3 cards that are on the table yet. So that is then 78 minus 3. This was not, no, minus 2, right? Yeah, this is 80 minus 0, 79 minus 1, 78 minus 2, I think. 76. That many. Cannot remember it, so paste it in the chat. Oh no, I want to get it out of it. Okay. Yeah, plus a little bit in the front. Let's just get around it by grabbing for anything that starts with 4. Oops, anything. And then count the number of lines. Yeah, that is not enough. I don't think it is enough. But okay, the whole output is wrong anyway. I want to see how this begins, obviously. That would be interesting to look at as well. 20 should be enough. Yeah, it just goes wrong immediately. Well, it sure starts right. I mean, we have 0, it adds 1, it adds 2. No, that's already wrong, isn't it? Oh, it skipped 0, 0, 0, 0, 0, forms a set, so that it skipped that. And then we get to 1, 0. Yeah, very good. And then the next one that we can add is apparently 1, 1. That does not form a set. Yeah, okay, I'll believe it. Then we get 1, 2, and then we get, okay, 2, 0 would be a set, it says. Yeah, I agree. That would be a set with, so 2, 0, 1, 0, 0, 0. That would be a set. And these two would form a set with ends on a 2, 2, 2, 2, 2. And 2, 2 is skipped as well. I think it mostly works, but printing doesn't work. Why is it printing all of this? Probably because they are 0 instead of F, 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 F. Why are they 0? Why are they 0? Oh, they are 0 because they are 0. Aren't they? Isn't that a thing? Just like initialize them as all zeros. God, 0. Yeah, I'm afraid that if I use this constructor, they're unknown. But I'm afraid I used another constructor. Probably this one. Definitely that one. But not for the first one. mean, we should go up to 8 cards before we get any trouble. Oh, that's really weird. And it worked also. You know, in the beginning it printed correctly. Unless it fills it only with 32 bits instead of 64. Have I been that stupid? Have I been that stupid? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 times 4. That's 64. But it is an int. I'm gonna add unsigned long here. If that is the reason, then I'm like, what? But okay, I thought that would work. Like said during this stream, like 3 times, that the compiler would be smart enough. Okay, that was not it, thank God. But I still had the feeling that maybe, you know, it stops printing with 3 because the next byte is all Fs. But when you override the first 4, then the rest is 0. So that looks like the initial value is 0, 0, 0, 0. All Fs, all Fs, all Fs, all Fs. Looks like it, doesn't it? I think I have to start with printing everything. So no longer stop printing when we encounter an unknown. So it's more clear what is in it. So yeah, if card is unequal that, do that. The rest is not printed. It's not breaking. It's printing everything. Unless it is 0FF. Anyway, let's remove this. Print everything. And I also want to know, I think, if it is a new card 8 or something else. So I do need a separator between the different card 8s. Choose a different separator, like, I don't know, vertical bar or something. Well, that's interesting. 33333. Oh, right, that's how it would print it. Yeah. So 3333 means 8 ones. Okay, so it is completely filled with Fs. That works. Therefore, it doesn't print any of these. And then at this point, bang, there are suddenly 0. Why? Why have they turned 0 here? Very surprising. Very surprising. How is that even possible, man? How is that possible? Time to debug, I think. Let's try a watch point. PDB, break main, run, next, list. Let's skip filling lookup tables. Break 215. No, let's just break on one card. Add one card. Continue, I guess. List unavailable. There should be only one bit set. Oh, that's not useful. Anyway, next. To this should just add the first card, yeah. Okay, card shift is 0. Make that 8. It's not equal to 64. Make a copy. And then the new card is 1. Is it an I possible, or is it a D? I don't know. Well, I wanted to print. I don't know. I think D is decimal. No, it's 1. Okay, next. Print M cards. Code index. That would be, oh, wait, yeah, I see it. M cards like that. Set print static off. Don't want to see that. Can print it in hex maybe. Okay, now we have something. Yeah, it's not easy to check when a certain byte changes of this. But maybe we can. I don't think that this pointer is changing, so let's print at this pointer to check that. D900. Okay, frame. Let's go a little bit forward. FindMatch. TA equal FF. New unavailable set. Here I'm setting it to 0 something, but that should be the next card. We talk about 0, right? See, it's set now this to 0, 0, and then we're going to OR it with a new card. Next. So now the new card has been added. I think nothing goes wrong, so just continue. And then we call I'm going to add the next card. Now I now should be unavailable. Continue, yeah, because we just added it. And this one is not unavailable. Oh, this is also unavailable. What that forms a set. Yep. And this one is not unavailable. So we're going to add that one. Card shift is set to 16. Still not 64. We make another copy. The new card is yeah, whatever it is. Yeah. This is still 0, I guess. Yep, so do nothing here. And if we do FindMatch with new card. Okay, whatever. Now we run over 8 things until we find that. I think I hear this is like where I want to know. what the contents of this thing is again. M cards, yeah, this one. So we still have the same thing. Okay, so this is 0, 0, I guess then. J0. And I set what are our matches? That will be 0, 1. It's already set. Ah. Oh. Dang. That doesn't work. Or does it? Actually, it doesn't work. Okay. Okay, now it compares with 0, 1. It's also not RF. And that matches 0, 0. So this is also already set. Doesn't do anything. No, wait. I'm adding 1, 0. Okay, I did do something. Of course, I did do something. I'm confused. Yeah, I mean, it's just setting unavailable. It's not really interesting, I think. Okay, here I'm ending with something that's it should now be the third one, right? Third byte. Yeah. It looks still okay. Let me print it anyway. Before and after. So before you still have this, and then do next, and now we have one more byte cleared. These two are cleared here. And then we set the next card, which was 1, 0, I think. Next, and then print it, and now we have yeah, okay. This is yeah, 1, 0 means 1, 0, 0 in binary. So that's a 4. That's correct. Confusing to switch suddenly to hexadecimal, but okay, so number of cards is now 3. And then we print it. Still everything looks just fine. And I'm going to print it like crazy. I think the next time that it is changed might already be, you know, where it is going wrong. Shall I just put a watch point on it right now? Oops. So this thing has an M cards in it. And that of course has an address. And I'm going to set a watch point on that address. And then we do continue, I guess. Or shall I just step? Anyway, next. Okay. One card. Unavailable. I don't care much about this. Card shift. Okay, +1, yes. +8. Still not 64. Make another copy. A new card. Let's print a new card. It's 5. Okay. That would be 1, 2. No, 1, 1. We're still here. Still Fs. We still have Fs. Matches is that equal FF. So set that. Shouldn't do anything. Okay, mask is that. What? Oh. Okay, we found the bug. This is an integer. And then the shift goes wrong and then I assign it to an int. Line 150, thank you very much. Yeah, if you just, a literal is just an int, so that's 32 bits, and now we shift it, and then you get nonsense, apparently. Should have done the same here. Static cast FF. Right, so now it is working in that. You gotta wonder why it keeps adding cards and then suddenly stops adding them and just replaces new cards. Why? Did I do that? Surely it must be easy to add more cards. Because for now I'll keep this different separator. Might make things clearer. Oh yeah, I did that here. 24. Okay, let's make this bigger then. Bigger, much bigger, because I want to see more than 8 cards being added for now. For a start. So let's make it 80. I don't know. Okay, add new card, and then we have 5, and then we have 6, and then we have 7, and then we have 1, 2, 3, 4, 5, 6, 7, 8, and then it goes wrong. Well, that is, we have 8, 9, which is correct, and all zeros. After that it keeps adding it. 9, 10, 11, 12, 13, 14, 15. Well, that goes pretty damn fast. Already 16 cards here, like instantly. And then it hangs at 16. That was my prediction, that there was only 16 cards possible. I mean, when I was thinking about it years ago. But okay, what's with the zeros here? Yeah, that's it. That's the array initialization. So we can fix that by changing that default constructor. So I have an array here, m cards being initialized like this. I only give it a single element. The remaining 10 elements are then default constructed, and that means it uses the default constructor of card 8, which doesn't do anything. Well, at least I would expect that to be, you know, random data, but apparently it's not filling it with random data. Anyway, unknown cards. Should fix it. Well, actually not 8 unknown cards with like 0 cards, right? And it's not unknown, it's more like unused. Should change that. Huh? Yes. Unknown cards. It's more like as unused cards, really. Yeah, okay, that looks good. Well, that looks a lot better. But I'm still slightly annoyed that, you know, it adds it to the left and then the new thing is added to the right. The new card 8. So I think I should print these things in the reversed order inside the card 8. Card 8 and then print on, print. And here we go from 56 to 0. So instead I should go from 0 to 56. Might as well take a nice number like 64 and use less than. Looks better, right? And the number of cards, I don't like this indentation here. Set width to. Which is defined in IO manip. Yay! It's okay. Now you can clearly see that it adds. Oh, it's just the same thing all the time. Adds more and more and more and more and more. And hopefully there's no set here. But okay, I think I already pretty much believe that because it hangs at 60. So now I'm going to run it like really. 18 cards. That was fast, but not fast enough because I think there was, well, this is proof that there's at least 20 cards can be found. 20, there we are. Well, that was pretty quick, I guess. I found all 20 cards or something. No, it still continues, but not really printing a lot anymore. Anyway. $20 cards, slowing down. This is going to take a long time. That is clear. A very long time, yeah. And that is what I was afraid of. That's why I stopped before, because I thought, well, it's going to take like 10 to the power 18 iterations. Now, of course, it must be possible to speed this up. That must be possible, absolutely. Because it, for example, one of the reasons it is so slow is that, say, once you have this part till here, then everything that follows is found in every random order. So it's going to, you know, the faculty of what is this, 8. This remains stable for the faculty of 8 combinations that follow. So that's like, yeah, no. I should generate them exclusively, I think, in incrementing order. This means that if there is, you know, 2 to, what do we just said here? 2 to something here, and then everything after that must be larger than 2 to. That would be a major, major improvement. How can I do that? Well, that's quite simple, actually. It is quite simple. Let's speed this thing up like a billion times. The only thing I have to do is add to my table the index of the last card that we added. I mean the card index, not the card 8 index, but the card index. Just getting it here. Int m last card index. Now let's put before here, whatever. Actually, at the moment I construct this thing. Yeah, no, let's add it here. The max is maybe something else. Like that. After the card shift. So the index of the last card that was added is 0 here. Yep. I mean, it's like literally card 0, which has also index 0. Then we can do add one card. And then we only want to add cards that are larger. Last card index +1. May only add cards that have a larger index. I think that's how simple it is. Except that I have to remember now, have to update it and remember it. So making a copy here. Okay, I'll also make a copy of the last card index. And then I can restore that afterwards. And then before we call add one card, I have to set the last card index to the last, well, yeah, to the card that we just added, which is also pretty obvious, namely is equal to I. Right? I think so. And it says here. Let's see what that does. That was a lot faster to get to 20. Still takes a long time. But I guess that, you know, as the higher this card becomes, the less cards you have left for the rest. So I think it's going to accelerate. We might even be already at halfway or something. We should be, because already half of the cards start with a 2 here. Huh? Changed. Well, maybe not. Maybe not. Maybe I'm still overlooking something that can be optimized. Because I feel like this is going to take a very long time still. Okay, I think it's time to go eat. I'll just let this run for a while, I think, while I have a break and stuff. So we consider this program finished. I hope you enjoyed it and could follow it. Is there anyone who wants to have this code? Can post it somewhere. Gotta wonder where it is spending most time, right? I want to benchmark this or no? What is it? Profile it. But there sure are a lot of solutions with 20 cards, man. Still cannot wrap my head around it, how that fits. Yeah, I could use 32 threads instead of one thread, but I would hardly get any faster, right? I mean, hardly. Well, 32 times, but that's what I mean. You would just say the second card here can be one of a lot of cards, I don't know. And then it would do the same thing as it's doing now, but then for all the cards here, say, at the same time. So that would still take a lot of time before this one is even changed. It should still take a lot of time. If you really want to speed up a program, you have to change the algorithm, not throw more CPU against it. That's nonsense. The only way to make something dramatically faster is fixing the algorithm. Although, I did already went through pretty much trouble during this program. To make it fast, of course. I mean, using all those bit fiddling, it finds if it adds a new card, it finds all the cards that are excluded as a result of that for 8 cards at the same time. All 8 here, and then all 8 here, and then again for this part. So it has to 3 times, it does 3 times a few bit operations to generate the cards that then drop out. Now we have, for each of those cards, you have to do a table lookup and set a bit in a bit set. So we can skip those. I'm sure it's possible to make it twice as fast just by changing the code a little bit. But to make it really faster, like that it is, I don't know, finishes in 10 seconds, we have to rethink the strategy, I guess, the algorithm. Or do something else smart. I mean, it was already pretty smart, I think, that, that I forced it to be in the increasing order. That did speed it up in, almost infinitely. But still not enough. Oh, that's very good, Rohit. That's the way to go. That way you learn something. I see you say open this link. Well, if you paste a link in the chat, then I don't see it. Nobody sees it. YouTube just suppresses links. That holds, of course, for everyone. I mean, this is a nice chat and we're all friends, and it should be possible to paste links, I think, except, of course, for the spammers, but everyone else should. But yeah, the few ruin it for the many. I cannot even turn that on. It's just not possible to paste any links in the YouTube chat. Okay, what shall I do? Shall I just keep it running and go eat? Or shall I stop the stream? I guess I can add a little window here. And then leave it running for a bit. pun intended. So I'm going to crunch some pea soup. Okay, don't wait for me, because I mean, if you don't, it's your decision. But when I get back, I'm not going to code for the foreseeable time. Maybe I'll just stop the stream when I get back. I don't know yet. Yeah. Never ending. Oh well. Still 9 viewers. Okay, I have my pea soup, so I'm eating. You know what I'm interested in? I think we're gonna stop it. Thank you. Yeah, no, I just heated up some pea soup, as usual, and did the dishes. What I'm very interested in is in I explained this before, but then you have to make a drawing. I'm bad at that and stuff. So anyway, in words, now you can think about set as a four-dimensional modulo 3 space of the characteristics, because it has 4 characteristics and each characteristic can have 3 values, and then each card in that space is a little cube, say, which then repeats every 3 in all directions, all 4 directions. And then if you pick 3 cards like that and they form a line, then you have a set. So I thought, well, if you take a 4-dimensional hypercube of 3 by 3 by 3 by 3, and you just put all the little cubes, aka the cards, in one corner, and you stack them up like 2 by 2 by 2 by 2, then you definitely don't have a line. Yeah, because those little 2 by 2 by 2 by 2 cubes don't even touch each other. You say, touch? Well, that's a modulo 3 thing. So just you keep repeating it in all directions. So I thought, well, it doesn't really matter, you can then rearrange, you can swap subspaces, or I don't know, it just doesn't really matter. So I get to a maximum of 16 being 2 to the power 4. But it turns out to be 20. By my same reasoning, I mean, in 4 dimensions, this is hard to understand, and in 3 dimensions, I could even, make a little model. Get some things, stack them up, and just look at it. That would be super interesting. So I wonder if we do this with 3 characteristics, then we have only 27 cards. And my prediction, as I just described, it would then be, so now we have just a normal cube, like the Rubik's cube, 3 by 3 by 3. And if I stack the little cubes in a corner, we have 2 by 2 by 2. That is 2 to the power 3 is 4, a maximum 4. So I'm really interested to know if it will not get any further than I said 8, right? Will not get any further than 8 different cards with only 3 characteristics. So how can I test that? How can I change this program so the number of characteristics is changeable? And I'll set it to 3 instead of 4. And then run it again. And then if you get more than 8 cards, I can visualize it. I can make a little model on my table here. And then I can see why that works. Let's put the constant expression first. I think that 6 there is 8 minus 2. And the 8 is 2 times 4. You cannot do more than 4 characteristics. I'm not going to change the program to have more than 1 byte per card. Yeah. So since the card is still 1 byte, a lot of code is going to remain. Now we have less than 81 cards. So this should be yeah, sorry, it's again 3 to the power number of characteristics. I think I did that before. That is just doable with the float, the standard power of the float. Yeah, I really clicked on it. Don't have an integer thing, but what? These things are not constant expression. That's ridiculous. hardly believe it. Maybe the documentation is not updated. What is it? Base exponent. So it doesn't know POW. Still have a chance. POW is a member of CMath, I guess. A converted constant expression. The hell is that? Let's see if it can do it like that. Get rid of the array first. Now it works. Ridiculous. Yeah, and the 170. Make a formula for that. I can just leave it as it is, I guess. The last bit. Yeah, I don't know. Shall leave it. I think we can reduce this to 3. It's 24. We never had more than 20 coins. Yeah, right. Okay, I'm done eating. Oh shit, I left the card shift less than 80 in. Which it always is. I'm an idiot. Ignore that. I didn't do anything because it was never larger than 56. But still, if it had done something, right? Yeah, to fill this, I guess I have to comment out one of them. Oh, that doesn't work. I wanted to make it a variable. Uh-oh, multi-loop. Yeah. Oh well, just hack it. Right, I want to put that there. Oh, no. That's pretty ugly. Okay, so this still works for 4. Almost immediately find set 20. Yeah, now the big drum ruffle. No, I want to save it for later. I'm gonna do 1. Number of characteristics. Prediction. The maximum number of cards with 1 characteristic that you can put on the table without getting a set is 2. Yay! Ricardo wins the main prize. Da-da-da-da-da. 2 is the answer. And the program worked. Next one. 2 characteristics. The maximum number of cards you can put on the table with 2 characteristics is 4. Let me think a little bit longer about it. Definitely 4. Yep, 4. Okay, and then now the thing I don't know. I have a guess, but yeah, that would be interesting. I'm gonna guess something, and then it will be interesting when I have it wrong. Because I think yeah, I don't know. I think it's just 8. I hope it's more than 8, but yes, 9. Ah, interesting. Okay. So I guess 8. Okay, yeah. Now I definitely have to make a model of this. How on earth did it get 9 in here? But how are we doing that? Especially the modal part is hard. I need little colored balls or something like that. Hell, can I really not draw this? Do I not have a drawing? I often need something to draw, and then I just want to draw straight lines, and I can never find it. I think you can. A GIMP cannot draw straight lines. Online draw tool, straight lines. Oh, straight line you draw. Okay, no. Well, they explain it, but then I still have to find it. Drawing tool. Create animated GIF. No. Click on this, maybe test something. Click the line tool, click and hold the mouse, drag it. Okay. And we can do that here. Oh, you can also draw a complete motorcycle. Start iDrew for free. Drawing. What is this? Thought I wanted to draw, and the only thing they want to do is okay, this one. Sign up with Google. Do I have to sign up? Why? All your Google Drive files. No. They cannot separate it? They're crazy. I don't even have anything on my Google Drive, but still. It's just ridiculous. Plus they support Facebook, so. Okay, does anyone know a site where I can draw straight lines? Image editor. No! This ought to draw a line. Mask site. Hey, I've tried it so often. I just want to draw some straight lines and I cannot find anything. It's ridiculous. And worse, there's no app on Linux for it. Not that I can find anyway. Let's see where I have it in. Oh. Yeah. Nothing, right? Never ask me to draw. What? No, again, this pencil, ruler. How does one change the pointer here? The color. Here's a color. Okay, now black. Let's make it red. Do I have an undo here? Nobody knows. Try Control Z. Nope. So you draw this and then, yeah, oh, sorry. just cannot be undone. Clear page drawing. Okay, that worked. Now, okay. It's not a straight line, but yeah, this doesn't exist. Straight lines and the internet is no go. It's not a square, but it's a cube. Change the color to green for the back, I guess. And then for yellow, we can draw all the lines on the surface, maybe. Oh, that was not a good idea that it just overlaps with the green one. But hey, they didn't give me a straight line drawing up. Yeah, it's not working right. I cannot, overlaps again. It's totally not going to work this. This is already too many. It's not possible to draw 27 little cubes. And this is even just the outside, can you imagine? I think I will draw all of them. Yeah, forget it. I'll have to make it, I think, really of some toys or something. I cannot draw this here. Forget it. I guess I'm going to... I want to see this so badly. I see it almost in front of me. But I do need something with a good ruler and straight lines. And I don't have it. This really pisses me off. Something that looks easy. Okay. At least we have a straight line here, I think. Okay, let's make this bigger. And then can I do like a rectangle even? Brilliant. Open rectangle. Okay, let me try that. Yes. Very nice, very nice. And now the only thing I need is to be able to copy it and paste it and change the color. There's colors. Oh, click to duplicate. I have it. Is this another layer or not? That's the question. Oh, it is. That was easy. It's not really the same like select. No. Oh, no. Undo. This thing has an undo. Wow. I don't have a select, unfortunately. Oh, everything is gone. It suddenly it became a mess. Fuck this. Okay, try undo, 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 undo. No. Okay, forget it. We lost it. Another one. Sumit Kumar, hello. I'm being extremely frustrated by drawing sites. I have 2 layers apparently, and they suddenly changed color. They became fat, and nobody knows why. But I never put this one down here. Oh, the sizes just jumped to unbelievable. I don't know where we have 5 layers. Did you see me add layers? They suddenly appeared. Oh, everything. Every time I do an undo, it just adds a layer. So undo is really add layer. Okay. So like a start over. That's pretty. Okay, yeah. Let's set the size to 1. That's possible. I'm going to draw a rectangle, I think. Like so. Make the full cube. Might need more space. And I want to move it. It's not possible. I think it's really, why can GIMP, I mean, not draw straight lines? That would be nice. Because I'm going to give this one up as well. Draw straight line. Oops. Straight line in GIMP. How to draw straight lines in GIMP? Oh, maybe it's. Click on the paintbrush, click the image where you want to start and end. Start drawing a line. Hold down the shift key. Oh. Mm-hmm. Okay. Graphics. GIMP. I'm just gonna do it locally. Try to do it locally. New. Okay. Pen. The size is a bit too big. Let's make that 2 then. Aspect, angle, spacing. Nobody knows what that is. We draw a green line, yes, but nah. Okay, now I can undo it. So I can draw a straight line by pressing. Oh, wait, no, didn't do that. Why? Okay. So we have to click here when I want to start, and then straight line. It doesn't even want to. Okay, the degrees. We have a straight line. It's amazing, isn't it? Okay, and now I can draw another one. Oh, I should have looked how long the line was. Approximation. Okay, well, it's the beginning. So yeah, I think I want to make a copy of this layer or something maybe. So I have a layer, make a copy of it. And then select, I think, by color. Select by color tool. And then transform colors. Yeah, many options. I think there was a color to transparent somewhere. Somewhere. Color to alpha. Yay. Color. What is it doing here? It's totally not what they wanted, I think. Doesn't do anything. Presets. Do even have color transparency, I mean. That might help. It worked. Okay. Now moving the whole layer. Sure, that was my intention. Can I film it? That is not visible. So I to suppress this selection without really changing the selection. Nobody knows. Nope. Well, I have to unselect it, I guess. Select none. Yep, it turned white. So at least something. Now you have to add a shitload of other lines. Line of this. Let me draw something like, no, not that. Grayish line maybe. Nobody knows which layer I'm drawing in. Okay, let's get some kind of yellowish. It went over the screen, right? Yeah, I did it the wrong way around, I guess. Oopsie, well, I can just, well, first I have to move it down. And then we have to make this background also disappear. Like that, and then we come to white. Why not? Because that would seem to work best, it said. Tools, color to alpha. It looks right immediately. Isn't it great? Give me a new layer. Yeah, I don't know. Black. There's no black here. Doesn't really matter, I guess. That was not what I want. Black. That's what I wanted. Select none. Okay. Right, and then you can continue drawing. Except that I lost my color. Oh, there's the color. Okay, 1, 2, 3. So a third here. I mean, click, shift. Not good. Sort of good. Not perfect. No, I don't like it. That wasn't 1/3. Slightly better, I guess. Slightly better. Should probably do that in a different layer, right? Make a new layer. A fully transparent layer. Yeah, this one. This is the new one, yep. Okay. It is quickly becoming too full again. Let's use some different colors. This color. The front. Yeah, yeah, yeah. Okay, I need to decide on which is what in terms of characteristic. That's my background. With what, Rohit? Okay, count for bits that you want to try to. I think all Thinking the background. What is my? That's really background. Okay, so I'm gonna need a new layer. Transparent. Can I rename this thing? Let's call this 2. Okay, let's call it 0. And this 1. And this 2. Zero, zero, zero. That would be here. Yeah, I think the best thing is to just draw a circle in it, which I don't have, over a sphere. A picture of a sphere. Because I cannot draw it. Cannot draw. I'm going to download a picture of a sphere and then put it in, I think. Images. A sphere. Give me a nice sphere. Images. That's a nice sphere. It's blue. On the red one. This one. Yay. It's even better. Okay, yeah. Fantastic. Can we save this? Properties of a sphere. How about save image? I am now in let's go to GIMP. GIMP. Here's GIMP. Sphere something. Okay, save. And then you have to import that here in a new layer, right? How do you do that? Open file. Open as layers. Open an image file as layers. Well, I just select one file. I guess it should work. Yes, we are open. Kind of worked. They're a bit big though. So now we have to scale this down. Scale layer. Stack and transform. Can transform. Rotate. Yeah, no, thank you. Layer boundary, layer image size, scale layer. That should do. And you can go down. Show it. Dude, what the hell? How am I supposed to know what happened? Okay, well that looks good. In fact, now how can I merge this down? Merge this layer with the first visible layer below it. Shift merge layers group. Control merge all visible layers. Shift control merge all visible layers with last used values. No, that worked. Yeah, well, except that I won't need a copy of it. So but okay, it's still the only thing in this layer. So you can make a copy of it, I guess. Let's move that one down for now. I'm gonna call this sphere. sphere. So, well, whatever. So, next one is in 001. Let's do just one X, Y, Z, and then the normal way, X, Y, Z. So this gives me Z, but of 1. Okay, is that doable? I think so. So I have to move it to layer. Sorry, this is my sphere. I have to make a copy first, I guess, and then move it up. To above 1, and then move it 001. That will be there. Yeah, okay. Except that I yeah, okay. Merge it down into 1, and then 0 should be there, and 2 should be there. Oh, this is the background because it's here. Oh, let's move this one up for now. It's like this. I think that works. This is layer 1. And I can move it a little bit still. Okay, it's just, I don't know, it's there. Next one, 0, 1, 0. Dus X is 0, Y is 1, and then Z is 0. So there's 1 here. So I'm going to go to sphere and then duplicate it. Make it visible. I'll move it to, Control Z. This one is, there it is. I'm going to put it in, yeah, in here. So above here, up. It's maybe not that clear. It's in the front layer, right? But it's not clear. Not clear at all. Okay, this must be in layer 0. So that's here. I'm going to merge it down. Okay, so now that's in layer 0, and that is the layer behind that. Okay, then we get 0, 1, 2. So that is all the way in the back then. So I'm going to go to sphere again and make a copy of it. And then make it visible. And then move it to there, and then 1 up. So basically here. I think maybe you should make them a little bit smaller. It's so unclear, this line like this. Yeah, it should be in the middle of the back face. Well, maybe like this, not that bad. It's not clear. Oh boy. Okay, 2. That was 0, 1, 2, right? Oh, wait, did I do that? 0, 0, 1 is this one. 0, 1, 0. 0, 1, 0. This is in the wrong spot. Could be kidding me. This is 110. We don't have that. Oh, we have that here. 110. Can leave it. But I need a 010 as well. And that's here, in fact. Copy, 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 copy. It's not a copy. This is a copy. Make it visible. Move it up. Simply up. Yeah. So, and this one is just next to it, so it really doesn't look like it. It really doesn't look like it. No. Maybe we should have put all the balls in their own layer. Doubt I can still move this one. Yep, cannot move it. Well, we can select it. That would work. Just select this part and move that. Oh, no, or not. What am I doing here? Just what is going on? Why would I not be able to select this part and then move it? Everything moves. Why? It still thinks I'm here. Can't even go away from it. Okay. If I kill it, I just kill it. But then I cannot copy this anymore. What is this? I do not understand why I cannot select this and then move it. Why? Doesn't make any sense whatsoever. The ridiculousness itself, but well. The shadow is not helping either, I think. It should not have added shadow. Yeah, I guess. And then I'm just going to erase this one again. Ridiculous but true. So I'll just do all the zeros first, right? So edit, select none. And that would be 0, 0, 0, 0, 1, 0. 1, 1, 0 and 1, 2, 0. 1, 2, 0. So there must be one here. Okay. Yeah. And then let's do this one. That's a sphere. So this is a layer 1, that means Z is 1. So 0, 0, 1, I do with that one. And then nothing else. Wow, really? It's the only one. Only on the layer 1. I have 1, 2, 3, 4. 4 in layer 0. Yep. And then in the back layer we have 0, 1, 2. So that would be this one shifted to there. Like that. Copy, copy, copy here. Wait, it's not correct. I want it this one, right? Kind of like that. Zero, 1, 2, I think. Yeah. And then we have 0, 1, 2. Okay, 1, 0, 2. 1, 0, 2. Down at the bottom there. One, 1, 2. That's the one that I already had. And 2, 0, 2. 2, 0, 2. That would be in the back here. So I can copy this and move that to here. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9 in there. And they do not form any line. And we can only see the line if I duplicate this cube in all directions. Yeah, and then I wish I could turn it around a bit. Rotate it. I think I have to write a 3D application for this to see it. It's not clear what this one is, right? That's the front layer. Okay, and the back layer and the one in the middle. It's just the only one in the middle. And then we have the front layer. That's 4 of them. Looks pretty random. Well, okay, this is not a set because if I go up, there's an empty one here. If I go that one, empty here. If I go that one, there's an empty one here on the back. If we go diagonally, this one is empty. I mean, everything is empty except this one, the layer, and then there's an empty one there. So we cannot go diagonally deeper. And I can go diagonally in the front layer, but then this one is empty. So no set. This one, same thing. Vertically, there's an empty one here, there's an empty one here. And diagonally is both empty here and empty there. Wait, no, it's not empty here. There's a front. That's there, yeah. So diagonally we can go like this, but then we got that one here is the same as this one, so that's empty again. So yeah. There's only 2 on the row, 2 diagonal, and those 2 is empty here. This one is empty there. This one is empty here. So these 2, yeah. So yep. And if I go deeper, I need that one, and then these 2 correspond to the one empty here, I guess. And that one there, and those 2 here. Yeah. And the one on the back is probably just the same shape, right? Does it have any symmetry of this one? No, not really. But it does have, when you mean this shape, means that you can put 4 in a single layer. We know that. It's one characteristic lower is you can put 4 in it. So we have 4 here in the front layer. And you cannot put more in the front layer. The maximum was 4. And the same in the back layer, also 4. And then if you want to go outside of the layer and make a set, so you have to vary, the characteristic in the Z direction must be different. So you use 1 ball from this layer, 1 ball from this layer, and 1 ball from this layer. And you always have to use this ball here. And that means that, well, in the bottom layer, that means that these 2 form a set together with this one. And these 2 form a set together with this one. So these 2 must be empty. And they are, I guess. They are. And in this slice here, this one must be empty. Because of that. Those two correspond to this one. And that's also empty. And then we can not only vary in this direction, but also in this direction, the X direction. So then we can go from this one to there, or from this one to there. No, wait, this one belongs to that one, sorry. This one is changing in every direction. So Z is different, X is different, and Y is different, yeah. So these two form a set together with well, you have to go one this direction and one. So it's +1, +1, and +1. So we do that again. I get +1, and I'm here. +1, I'm in a corner, and then +1 for the Z. So that's this corner here, the front, which is indeed empty. Yeah, it's not making anything really like obvious, if you understand what I mean. So I don't think it's an eye-opener of why 9 is the maximum. Or how to arrange them to find that. Let alone to now extrapolate this to 4 dimensions and then understand why it's 20 instead of 16. Nope. But I can't make a better drawing, I'm afraid. This is then where we stop. Okay, I'm going to give Arrowhead some attention. I'll go to Discord. Keep moving my top window. In general, nothing. I don't see a link in Discord. Post Bunny posted the link today and nobody else did. Yeah, Rohit, well, it's good that you did it, but I do not see any link on Discord. On my server, anyway. I think I'm going to stop the stream because, well, this has been beaten to death now. I guess I don't, I'm looking up to it. I don't like it, what I'm working on. But tomorrow, I guess I'll continue with my Vulkan engine. It's way too difficult. Crazy Marcus, hello. Yeah, well, you didn't miss much. Last hour I've been doing it. I made a drawing, yeah. This. So that's my. I already deleted the file, but output of my program generated basically this, and then yeah, didn't give me any insight. But I'm going to stop because I said so. I'll be back tomorrow, I think. Yeah, it's too late.